Howdy, 7th grade. Today I want to look at how scaling different things can affect their perimeter, their area, and their volumes. We're looking at a whole bunch of stuff, and I could just tell you in about 30 seconds how scaling affects the perimeter, area, and volume. That wouldn't be any fun. So instead we're going to try to figure it out ourselves. So first I want to review real quick what scaling is. So what is scaling? Because if we don't know what scaling is, it's going to be really hard to figure out what effects it has on these things. So scaling is when we take one thing, let's say this square has sides of 1 and 1, and then we're going to scale it by a factor of 2. And what that means is we're going to multiply the sides by 2. Scale by factor of 2. That means my sides are now 1 times 2 and 1 times 2. And this should be a bigger square. And let me make that a bigger square. That looks awful. Here we go, a nice big square for us. And our sides are 1 times 2 and 1 times 2 because we scaled it by a factor of 2. So we want to know, when we do this, what's the effect of the perimeter, the area, the volume, all that jazz. So when I look at these things, I like using rectangles and squares because that makes the geometry pretty easy. And I want to see the effect on the perimeter, the area, and the volume. So let's start by looking at the perimeter. And I don't want to use 1 and 1 like I did here, because if I use 1 and 1, then I'm going to only know things about a square that has side length 1, and that's not too interesting. So instead I'm going to make my square, and it's going to be a rectangle, and the lengths of the sides of the rectangle will be A and B. And I want to scale by a factor of, and I can pick any variable I want here, but we're going to call it C. That way we're using A, B, and C. Seems pretty easy. And it's going to make some sort of bigger rectangle where the sides can be A times C and B times C. So we got C times bigger. And I want to compare the perimeters here. So if I have my perimeter of my first shape, so we're going to call that the original shape. I want to find the perimeter. Well, that's easy. I just go around my rectangle and I add up all the sides. This is A, B, and B. So my perimeter is equal to A plus B plus A plus B, which is going to be, I have an A here and an A here, that's 2 A's, a B here and a B here, that's 2 B's. So that's not too bad. So if I go over here now and I look at my new shape, we draw a line so we know what we're talking about, new, I have to go around this new shape with sides AC, BC, AC, and BC. I really should have made that a D instead of a B, so I'd have AC and DC, but anyways, old rock bands aside, I should be able to go around here and say my perimeter is adding up all the sides, which is AC plus BC plus AC plus BC. If I keep working on this, I can find that's equal to, I have 2 of these AC things and 2 of these BC things. And I can actually factor a C out of this, which is equal to C times 2A plus 2B. So what I'm going to write that as, real quick, just to make sure we see this, our old perimeter is equal to 2A plus 2B, and our new perimeter is equal to C times 2A plus 2B. So what that means, if we look, 2A plus 2B is both here and there. Our new perimeter is going to be equal to our scale factor times our old perimeter. So our new perimeter is equal to our scale factor times our old perimeter. And that makes sense because all the sides got our scale factor times bigger, so our perimeter is going to be the scale factor times the new side. So we're going to do the same thing with area. So I'm going to do this in a slightly new color. And we're going to start off with our A by B rectangle and scale it up by C to get to my AC BC rectangle. I'm looking at this, my old area. We find area of a rectangle by multiplying the base times the height, which in this case is B times A, or just BA. And on the new area, my area is going to be my base times my height, base times height, which is BC times AC, which is going to be BAC squared. So what I can say now is my new area is going to be equal to C squared times my old area. And the other way of putting that is my scaled area equals my scale factor squared times my original area. And that's not too bad. That also kind of makes sense. So both of these, we've got two different dimensions with both multiplied by c. So I've got two c's here, and when I multiply them together, I get a c squared. So when we have a scale factor, our area goes up by the scale factor squared. And we got one more I said we'd get to, which is volume. So volume, squares don't have volume, they just have area. So to do that, I'm going to need to draw a cube, or a rectangular prism at least. And we're going to say that the sides here are going to be A, B, and C is the depth. I'm going to use D as the depth, just so I can use C as my scale factor still. So I'm going to scale this up to some bigger prism here, where it's going to be AC, DC, finally got it, and BC there. So my AC, DC, BC prism is what's happened when we scale up by C. So now I need to find the volume, which is going to be the base times, the volume is going to be the length times width times depth. So length times width times depth, which for me is going to be A times B times D, ABD. And that is for my old prism. So for the new prism, I can say that my volume is equal to the length times the width times the depth, which now is going to be AC, BC, DC. And if I want to put all those C's together, it would be ABD times C cubed. So again, I see the same thing for volume, just with something multiplied on. So I could say that my original volume is equal to, sorry, I wrote that backwards. Let's try that one more time. We're going to have my scaled volume is going to equal the original volume times my scale factor cubed. So a great way to look at this is that volume is something that takes place in 3 dimensions. So we're going to have our scale factor to the power of 3 here, because volume is in 3 dimensions. 3D, third power. And if we go back up, we can see that area, which is a 2D thing, so area is 2D, and here we have this to the second power. And last but not least, if I go all the way up, I should be able to find for my perimeter, here it is, perimeter is 1D, and my scale factor here is to the first power. There we go. So as a general rule, It goes up by a factor of the scale factor to the power of whatever dimension you're in. So volume's 3D, so it'd be to the third power, area is 2D, so it's to the second, and perimeter is 1D because it's just a length, so it'd be to the first. In any case, that's how this works. So I will make sure we're working on the bookwork. I'll see you all in class tomorrow. Have a great day.